So one thing that I want to note to start with is that I did add a link onto Piazza, which will take you to a read version of my overleaf of the syllabus. So you'll notice that if you go to the course outline section, I'm trying to update it to reflect more what we're actually covering in class versus what I was expecting to cover. And I'm also trying to add some additional references here as well. So especially, say, for example, if you're new to Python, right, there's a link in here to Python tutorials, some links to some specific things that we'll be discussing today, so you get a little bit more quick references so you're not having to look for all of them yourselves. Right? It might not cover everything that you have questions about, but hopefully it gives you some good resources if you have some initial questions about what it is that we're talking about. So the big first topic that I want to talk about is in terms of the lab reports. So the first thing that I want to iterate again is read the rubric. Right? So I took the rubric and I graded specifically based off of the rubric. And I noticed that a lot of you were missing several sections that are detailed in the rubric. Right? So make sure that you take a look at your rubrics before you do your submissions. Right? Keep in mind that these are reports, right? So 3 bullets and 10 pictures is not a report, right? You should have some writing in there. We're mostly juniors, seniors, graduate students, and whether you like it or not, writing is going to continue to be a part of your life, right? My partner is a field service engineer, and he regularly writes 100 plus page reports. And missing details can cause a lot of problems. Right? There's one little detail that he remembered to include in the report and saved his company a $100,000 warranty claim, right? Because he made sure to put details of what it was that he actually did. So I want to kind of get you in the habit of, how to write quality reports, make it clear what it is that you did, why you did it. So then if you go back, right, I should be able to, 5 years from now, hand your report to somebody and they should be able to tell, here's what they did, here's why they did it. Want to make sure that it reflects the team's work and experience, right? So it's a team report, right? So if I see a report that's just all, I did this, I did that, and it's completely tangent from the tasks of the lab, right? That kind of indicates to me that maybe there's only one person in the group that's doing something and not actually collaborating with the rest of their team, right? So we want to make sure that we're reflecting the fact that we want this to be a collaborative working experience and that everybody should be having some kind of experience with the material. I did create a little template, kind of give you an idea of what might be good to kind of make sure you get all of the points, right? So start off with a highlight section, right? So just a brief, here's what we got out of it. So like say for lab 1, right? We set up a virtual machine, we figured out some Linux command, we created a GitHub account, right? So then if I hand this, say, to my boss and say, well, here's what they did for lab 1, right? He might just look at that and say, oh, good, they learned this, this, and this, right? That's the purpose of the highlight section. And then for the problems, right, it'd be good to have, here's a summary, right, really succinct. Here's the problems that we encountered. Here's kind of the main way that we solved it, right? So couldn't connect to the internet. We had to change the adapter settings. And then you have the details. Well, we found this solution from such and such a resource. Here's the steps, right, to access this. Here's the images to walk you through. So if somebody was going to do this themselves, they could actually follow your guide and be able to debug their problem if they encountered the same thing. And the purpose of the initial part is they could take a look at the problem summary and say, yes, this matches the problem I had. I haven't tried this solution summary, so I want to go down to the details of the debug report. Right? So it kind of helps organize so people can look at what they're actually interested in looking at. And then when you get to the actual sections of the lab tasks, right, you want to provide some details of what you did, why you did certain things, include images. And when you have images, use descriptive captions, right? So it's very likely that some people just kind of skim through all of the images to see what you did. So if you have a descriptive caption, then they know here's why this was included. Reference it in your text so you can provide more context as to, this image is showing how to access the settings, right? Something like that. For the feature section, this is really designed to show that you're actually thinking about what you did in the lab, right? So where might you use this material again? What are some additional things you might want to look into? Or maybe you take a look and say, well, I think based on what we did here that maybe for the next lab we'll be doing this, right? So kind of giving some insight as to what you think the next steps might be. And then provide a collaboration summary. So just kind of give me some insight as to how you're working together, right? So for this example, like, well, this person had some experience, so we leveraged that. These other people had some questions, so we brainstormed as a group to figure out, why did we use this certain command? What does this actually mean? And here are some resources that we found or information. And if you have references, use a proper citation format. I know it's a little bit annoying, but if you just include links in your report, Gradescope cannot click on links, right? And if you were to print out a PDF and send it to someone, it turns out that you cannot click on the links, right? So we want to make sure that we have references so no matter what format your report is in, people can actually access the information that you're providing to them, right? So things that might be a little bit annoying to remember to do at first, but good habits to get into early on when you're doing these types of submissions. And your report should also be standalone, right? So what I mean by that is, like for some reports, they just had question and answer without any context, right? So I have a rough idea because I looked at the description of the lab. If I hand this to somebody else and say, oh, here's what they did, they would have no idea what it is that you're talking about, right? We want to make sure that this is a standalone report so that you can understand everything that's in it based off of just what's in the report. One thing that you'll notice with my outline, I had a section for problems. If you didn't encounter any problems in the rubric, there's some alternative things that you can explore that correspond to the points that you would get for the problem solving section. So I know because this was the first report, kind of getting the details and all of that. Feel free to let me know if you're interested in making some changes and resubmitting, and I can reopen Gradescope for that. Take a look on Gradescope, give feedback, and as you go through, you should be able to see, because you can click on it, add like text annotations, things like that, for things that you might want to consider changing if you go with the resubmission, right? So that's an option for this one. Hopefully that's helpful. Just trying to get good habits started early. All right, so I'm going to kind of continue on with talking about Python. Yes. So I'd like to have those, let's say within a week. So then I can post the grades to Gradescope, and then I can adjust after. Because if you don't put anything in until like 3 weeks later, I'm probably not going to think to look and go back. And then it's also not really fair to the rest of the team if somebody had like they did really good contributions and then it gets ignored because I didn't see it, things like that. So I would say within a week would be best. Right. Right. So with Python is really a object-centric type of programming language, right? And so what this object-oriented programming is really we're trying to structure our program by utilizing objects. And objects are a way that we can bundle together related properties and behaviors. Right? So let's take, for example, if you had an object which is a point robot, which is moving on a 2D plane. So some of the properties that you might have is the current position of the robot, so it's like the XY position. And you might also keep track of, say, the number of movements that it's made, right? So kind of the lifetime of the robot. And you might have some behaviors associated with it, right? So you have your 2D grid, and maybe it can move up, down, left, right, right? So we can combine all of these properties and behaviors into a single point robot object, right? So it really helps for organization of our code, and it can also help really inform the structure of our code as well, right? How we actually organize the program. And so that's the main difference between your object-oriented programming versus your non-object-oriented programming. Because when you don't use this type of programming method, really all you're using is objects just to represent data. Versus, I would say, with these types of objects, right, you're grouping together related things to help organize your code in a clearer way. And so the main way that we form objects with Python is to utilize classes, right? So let's take, for an example, let's say I have a bunch of bins in my storage room. And for each of those bins, I have an ID, a number of items in that bin, and the location, right? And so if I'm just storing this, I could say based off of what we've learned before, maybe I just want to use lists, right? And so for each list I have, for a certain bin, here's my ID, here's a number of items, and here's the location, right? Now the question is, what happens if, say for bin 2, I didn't have an item listed? Or what if, 3 days down the line, I want to access the number of items in bin 2, right? How do I know what that was, right? Was it element 1? Was it element 2? Right? You'd have to go back and explore a little bit. So we could say, well, maybe the way that this is structured, we could use something like a dictionary, right? So then for each one, you have the field associated with the ID, for the items with the location, right? So then later, if you wanted to look up the items in bin 1, then you could say, bin 1, and you can access the items field and get that value, right? So that would work pretty well. But let's say that I know I'm going to be moving around my bins, and I'm going to be taking things out of one bin, putting it in another bin, right? Something like that. So if you had that kind of situation, right? So maybe I want to move stuff from bin 1 to bin 2. That means I have to go in, change the bin items field for bin 1, and then change it for bin 2, right? I hope that I did that conversion correctly and I used the same numbers, right? So what I could actually do is I could use something like a class, and I can add functions which would allow me to do those types of movements without having to manually control all of these dictionaries. Right? And so what's also nice about using classes is that you'll see, and with some of these examples, it kind of makes sense that objects often will map to real world objects, right? So things that we think of as having properties, as having behaviors, lends itself really well to creating objects in the programming language. It also makes code more reusable, right? So if I have something like a class, I can make a bunch of, say, my bin class, right? So I can have a class that has certain properties, and I can easily make a bunch of those that have similar properties, and it makes it really reusable. It also helps for modularizing your code, right? Because we're breaking it up into different classes, which are grouping together our properties and our functions, right? So then we can have a bunch of classes, say, in one Python file, and then we can import those classes and use them in a dozen other files, right? So we don't have to keep rewriting all of these classes. We can write it once and reuse it as much as we want. It can also make your code a little bit more flexible, a little bit more adaptable. Is that something you're interested in? You can look into a little bit more what more complex things you can do with things like classes. Of course, keeping in mind that it's not the be-all, catch-all, right? So if you only are storing data right? Something like a dictionary is probably fine. If you only have a single function, you probably don't need to write a class for that. Okay, so the big thing with Python is they really push for code that is simple and readable, right? So if you can do something with something that is simpler, use it, right? So really only use your classes when it makes sense to use it. So let's take a look at what a class is. So the class itself, you can almost think of it as like a blueprint for your class. So it doesn't actually contain any information, but it's going to tell you, say, what properties you should supply if you want to create a specific object that is of that class. And so you can declare certain attributes of a class, right? So this is things like your properties and your data. And so these are kind of like the static parameters of your object. One thing that might be a little different if you're coming from a programming language, say like C++. So in some languages, there is a distinction between private and public attributes, private and public methods or functions within classes. For Python, they don't have that, right? So you can't actually really completely hide something from the user. So they have a lot of conventions to try and tell the user, maybe you shouldn't be looking at this. You can if you really, really need to, but I really don't want you to mess with this. And so the convention is if you have an attribute that is part of the class, but really the user shouldn't be accessing it, you put 2 underscores at the beginning, and that's a way that if the user tries to access the attribute, they know that if they have to put in 2 underscores, then it's meant to be private. And then you can also specify for a class the functions that you can use on those class objects and within that object. And so typically we refer to the functions that are associated with the class as methods. And similarly, like the attributes, right? There's no way that you can completely hide the functions from the user. There's some different things that you can do to try and make it more and more difficult, right? But they can always kind of go around that if they really want to. So the convention is if you have something that's meant to be private and only used kind of behind the scenes, you surround it with double underscores, right? So we'll see some examples of common ones that you encounter for these types of methods, right? And if you see somebody refer to them as dunder methods, right, double underscore methods. And then collectively, these methods and these attributes, you'll hear them referred to as members of the class, right? So just all of the things that are associated with that particular class. And so if the class itself is the blueprint, if we actually populate this blueprint with specific data, then we're going to refer that as an instance of the class, right? So with an instance, so if we have, say, the class is something like the bin, where we can supply the ID and the number of items, right? Once we actually create an instance of the class, it's going to have a specific ID number, and it's going to have a specific number of items, and so that's an instance of the bin class, right? So we'll see some examples, or hopefully that'll make a little bit more sense. But what's nice about using the class definition is you can also have multiple instances of the class, right? So a bunch of objects that are related to each other in their structure, but they have different characteristics. Right, so the format when we're creating a class, which I broke the convention, that's really a great way to show the example here. Right, so by convention, we want to use capitalized word name when we're defining the name of the class. And so we start with the keyword class, and then we get the class name, and then the colon. So as we've seen with if statements, the while loops, all those kinds of things, right? Usually when we start with that initial definition, we end with a colon, and that's how we know that we've done that initial specification. And then after that, you're going to supply the attributes, right? So you could have some attributes up here, which are considered to be class attributes, right? So what this means is that for every instance of that class, whatever this attribute is would be the same for all of them, right? So if I had, say, a class which is cat, I could have the attribute be maybe the scientific name of the cat, because no matter which cat it is, it should have the same scientific name, right? So that's where we would use something like a class attribute, right? So this is the first example of one of those dunder methods, right? So pretty much anytime you define a class, you're going to have this def init. So what def init does is it tells the program when I create an instance of a class, right? So I actually create a specific object of this class type. Here's how I need to initialize that, right? So one thing that's really easy to forget, the first argument for any of these needs to be self. Because what happens is that when Python creates an instance, it takes the instance and passes it as the first argument, right? And so technically you can call it whatever you want, but if you put it as something other than self, anybody who's used to Python is going to be very, very confused, right? They're just going to be expecting self, right? That is one of the interesting things. Python it lets you do pretty much whatever you want, but there are some very strict conventions that people who use Python follow and get kind of confused and can tell they're not a native Python programmer, right? So some interesting things, as you see more and more code, you'll see a lot of these conventions pop up, right? So when you initialize, you can also provide additional arguments. And then what you can do is from these arguments, self dot, right? So kind of like with the dictionaries, right? We're telling it some field, which is the attribute of that class, and then we can utilize the argument to specify those attributes. Right? And so you could have other things, so maybe you do some math in here to assign attributes, right? But for a lot of them, maybe it's just this simple kind of assignment. Right. And so then if I want to actually create an instance of the class, then I would give the class name, whatever that class name is, and then I would supply whatever arguments I need, and it's going to create an instance of that class, and it's going to initialize such that these arguments of that class. Right, so it'll probably make a little bit more sense if we take a look at an example here. Right, so I'm going to have a class named cat, and I decided that the two properties that are most important to this cat class is the name and the color of that animal. So I would say when I want to define a cat instance, I need to provide that name and I need to provide that color, and they're going to become attributes of that class. So then I can initialize and I can say, all right, I'm going to make a cat with this name and this color. And then what I can do is I can access the attributes of that class using dot notation. And I can say I want the name attribute of this instance of the cat, and it's going to return that attribute to me. So now the question is, what if I do print on the class itself? All right, well, let's take a look here. All right, everybody see that I zoomed in a little bit, right? So I have my cat class here, right? Invalid character. Oh, because I copied from slide. Right, so good thing to learn if you copy code from somewhere. Always check and make sure that that makes sense, right? right? And because I also copied here. All right, so I said I can print the attribute of that class instance. And if I want to print the class, right? So this is telling me that this is a cat object, and here's the memory location. Right? So probably not the most useful if you're trying to figure out, right, I want to make an instance of cat, what do I need to give it? Right? Or, if I actually want to see all of the attributes of it, right? I want the information about this instance. What is it telling me? So what we can do is we can use another dunder method, string, this str. So what this is going to do is it's going to tell the program that if I try to convert this into a string, here's what it should look like, right? And so we define this dunder method. We use the return keyword, and it's going to return this string. Right, so these are special types of strings, F strings, and I have an additional link to some more information in the syllabus. But what we can do is we can start our string with an F, and that tells it that it's an F string. Yes.
Just kind of curious, is that memory location?
The last part again?
When you were showing.
Mm-hmm. I would have to look at that a little bit closer. That's a little more CS side. Yeah, because what's interesting is, so if I make, another instance of, because it's the actual memory location, right? So if I make another instance of that, right? So you can see that the memory location changed, even though it has the same name, everything, it stores it at a different memory location. So that's really more in the memory. And I'm not a CS person, so I'd have to dig into it a little, but processes would be, I think, in a different area. But yeah. All right. So what this F string is allowing us to do is, when we have these curly brackets, we have it essentially evaluating what's in the curly brackets. So what's happening here is I have a string, cat name blank is blank, and it's filling that in by looking at the attributes of that instance of the class, right? So this self, that's that specific instance of this class, and it's pulling those attributes. So now, if I was to create this same cat, and I said print cat1, it's going to print this string, filling in the attributes of that specific instance. Right, so a great way that we can get more information. And what's also nice is with classes, we can change attributes, right? So let's say, I misput that in. Actually, the cat is black. So I can change that attribute. And if I print, then what you would see is that it would change the attribute based on this current state of that instance. Right? You can also delete full instances, or you can also delete specific attributes. So if you do del cat1, that would delete the entire instance. You can do del cat1 color, and it would delete that attribute from the class. Now, if I do this, and I say del cat1 color, and then I say print cat1, I'm going to get an error. Right? Why? because when I say, okay, it's going to go to this string Thunder method here, self.color no longer exists, right? Because you actually deleted that attribute from that class, right? So you're going to get a error message that's going to pop up and say that this instance doesn't have attribute named color, right? So some interesting things that can happen if you play around with this and you can take a look. So you can also utilize classes to inform your program and organize it in different ways by looking at the connection between classes, right? So one way that you can think about it is inheritance, right? So you could have child classes which inherit from parent classes. So this is typically used to model ISA type of relationships, right? So for example, I could take my pet classes here. First, I'm going to show you a bad example, right? Which was my first writing, and then I'll show you a better example, right? So my first bad example, I said, well, I'm going to have two classes here. I'm going to have a cat and I'm going to have a dog, right? And then I'm going to say that I have another class called pet. And so this pet is inheriting from cat and dog, right? And so as you can see, I wanted to print some information, saying that this animal is a certain type and here's some information about it, right? And right off the bat, you can probably tell it looks messy and not clear. So typically when you're using Python, if something starts to look messy or wrong, you're probably not doing it right? So if we think about these two classes, these sets of classes, if we really think about it, what it really is that cats and dogs are pets, right? A cat is a pet, a dog is a pet. So it makes more sense that it inherits traits from the pet class, right? So for this example, well, all of my pets, I'm going to say, have a name and they have an age, okay? And for a cat, it's going to have this super here is saying, I'm inheriting from this pet. I'm going to provide this name and age to this super class, which is that pet class. So it's calling the initialization function for that pet class. And so we're feeding in the name and age. And so we're actually inheriting those attributes, name and age, from this other class. Okay? And then I say, well, something that's unique for a cat is, say I want the color, right? So now I add an additional attribute which the pet class did not have. Okay? And similarly, I could say, well, the dog is a pet. It also has a name and age like a pet. But the difference between the cat and the dog is with the dog, we usually specify the breed, right? So I added an attribute breed. And so what's nice about this, right? I have my pet class, right? So now when I call the string on something which is a instance of dog, what's happening here is the string is first calling the pet string, which if we go up to that, is going to print the name and the age. And then it fills in this cat is a color or this dog is a whatever breed, depending on which type of instance or which type of class it is. Right, so I'm going to post all of these as well. So if you're a little bit confused and you want to have more of a conversation about these, why is why did I say this is better than that, right? Does the other still work? We can have those kinds of conversations if you're newer to Python and wondering what's actually going on with these, right? So that's one way that you can connect different classes is by actually doing this type of inheritance, right? So actually kind of gaining characteristics from another class, right? So one thing, of course, is that this could lead to really long hierarchies, right? So you're, maybe parent inheriting from a child, inheriting from a parent, inheriting from a grandparent, great grandparent, right? So that could get a little bit messy. It turns out that a little bit more advanced topic, you can do multiple inheritance with Python, right? So probably for a lot of stuff that we're doing, we won't get into anything, that complicated. But it's something to be aware of if you're interested that does exist. So that's one way that we might kind of think about connections between classes. Another common way is composition, right? So that you could have an object which is composed of other objects. Right? So this is typically used to model a has-a relationship. Right? So one class has another class. So let's say we have something like an outfit class, right? So as part of an outfit, we have footwear, legwear, torso wear, because I couldn't think of any other term for it, and headwear, right? So all of these subclasses are part of the outfit class. So I take a look here, right? So I could have all of these component classes, right? So one thing that you'll notice that I started doing that's different from the other examples. This, right? So we learned before that the triple quotes here give us a multi-line string. What's nice about these multi-line strings is that if I do help of that class, it's going to return this string, right? So it's a great way to give some additional information to your users to help them to actually utilize your code, right? So I have a bunch of different classes here, and you can run through all the different ones, right? And so my outfit has all of these subclasses, and so it can actually be composed of those subclasses, right? And so it's actually going to take in some information, it's going to feed them into the components, and those classes are going to become part of that bigger class. Right? And so if then I create an outfit, and so I provided some information about, feet, legs, whatever here. Now, if I wanted to access the footwear color, I can actually go from the big class to this kind of sub attribute, which is also a class because it's a component class. And then I can access the specific attributes of that component class. Right? So it really helps to potentially organize your information of your different classes. Or you could also have something maybe like a robot, and you have subclasses which are maybe arm and the torso, or maybe you have subclasses which are wheels, right? Different things like that. And what's nice, right? So I also have string here, right? So when I take and print that, it's actually giving me the string from um, from my footwear class, right? And if I do, I think I did that. So you can see this information that I provided. It provided to me with the help function, right? So it gives you that additional information to give some people insight, right? So it tells you, here, this should really be a Boolean, that should be a string, here's the parameters that you should provide, right? It gives the user a little bit more readability, okay? So I also have a little bit more complex of an example, right? So I have the bins class, kind of like what I talked about before. And so for this one, right, we have the initialization. And so this one, I made some improvements here utilizing properties, right? So this is something else that if you want to explore between this bin and that bin, some additional things that you can do with classes, right? So what I decided to implement is that I wanted to make sure items was an integer. So in my initial writing, I created an internal function which checks to see if it's an integer. And I have this test value here. And when I initialize, I have to call that function and see whether or not it succeeded. I have some additional functions lower down, which says, well, I want to move items from one bin to another. Tell me how many items. And I said, well, I also want to check and make sure that that's an integer. And I have this mess of stuff to check and let you know if it wasn't an integer. And it turns out if you use parameters, that you can actually create a setter. And so you can check whether or not that value is an integer, and it'll check that everywhere, right? So if I try and set within one of my sub functions that attribute to something other than an integer, it'll throw an error, right? So it turns out that as you get more experience and you look at different ways to do things, that there are a lot of ways to make your code more efficient, more readable, right? So you don't have to worry about that early on, but just kind of be aware that if things start looking messy, maybe start looking at some resources to see if there's a better way to do it, because there probably is, right? So if you start getting things that are circular, you have to write a whole bunch of functions, take a check and see what you might be able to do. Right, so this has some examples where I'm taking actually multiple instances and changing things between them. Right, so I actually have some cases here where I'm moving stuff from one bin to another, so you can see how that might work. Also showing the help function, right, so I can get some additional information from not only the class itself, but also the methods within that class. And there's also an example error case, right, so I'll show you what happens if you try and supply a non-integer value. Right, so some code for you to potentially explore. And of course, if you have any questions, want to take a look at any of this, let me know and we can dig into it a little bit more. Right, so I do have some resources. So some of these are the same. I did add Real Python. They have some good videos and stuff as well. Some things that I didn't talk about. So there's actually different types of methods if you're interested. Methods which are specific to the instances, right? So those created objects. Turns out that there's also static and class types of methods, right? So you can do slightly different things depending on what it is that you're trying to do with your classes. I kind of briefly showed you the idea of properties, right? So there's a resource if you are interested in seeing what the power of those are. Especially if you're new to Python, open a Python terminal. Right, so what I mean by that is open a terminal and type Python, so that it goes into the Python environment, and type import this, right? And take a read at what you see there, because that's going to give you a little bit of insight as to what the Python mentality is. Or in other words, if you ever hear somebody like you go onto Stack Exchange and they say, well, that's not very Pythonic. That's a word that they utilize a lot to basically mean that it doesn't really adhere to what they think is good Python code. And the main things that they focus with Python is it should be simple unless it needs to be complex, and it should be readable, right? So those are the big things that they really push. And this resource here gives you a little bit of additional resources to see, some of the things that you might want to think about when you're writing your code. I know kind of the way that coding, I think, is learned by a lot of students is a little bit ad hoc, and you just kind of quickly do quick prototyping and you don't really think about, looking at code and reusing code. So we don't really think as much about, if I give this to somebody else, are they actually going to know what it does? Right. So kind of that Python mentality of coding takes a lot of that into account and really tries to make you think about, here's some changes that you might want to make. And something like Python checker is going to help you out a little bit with that, right? Making sure that you don't have lines that are too long that are hard for people to digest, right? That you have proper spacing so it's a lot more easy for people to read what it is that you've written, right? So definitely a lot of stuff to explore as we start writing a little bit of code. Or I'll try and give some guidelines as to, or maybe some templates as to what the code might look like. So for those of you that are learning, it gives you a little bit more of a chance to figure out some of this stuff. Because I know you can take, multiple classes on Python and still really probably not dig into all of it. So don't get overwhelmed if you're confused by anything. You can definitely have side conversations if you're interested in more. All right. So any questions about material so far, lab stuff so far? Okay. So I want to give you guys some time to get together, maybe take a review at lab 1, do some work on lab 2, whatever it is that makes most sense to you for the rest of class time today. And of course, we're available if you have any questions or any problems with anything.